Okay, so we've got a chemist who mixed 3 liters of a 30% sulfuric acid with a sample of 80% sulfuric acid to obtain a 60% sulfuric acid. How much of the 80% sulfuric acid was used? So we're going to try to draw a diagram of what's happening here. The first thing I'm going to figure out always is what the final mixture was that he obtained. So from the reading, he mixes a 30% with an 80% to obtain a 60% sample. So the concentration of what he obtains is 60%. This is important. Just get the final mixture first. Then what you put in these two don't matter because he mixed a 30% and an 80%. So I'm going to put a 30% mixture here and an 80% mixture there. What's important is that when these two get mixed, they better get a concentration somewhere in the middle. For example, a 30 and an 80 can mix to give me a 60, but if I mix a 30% and an 80%, there's no way I can get a 90%. So whatever concentration is the final mixture must be a number between these two mixtures. Then I read the problem again. A chemist mixed 3 liters of 30% sulfuric acid. So I already know how much of this guy he used. How high was this? 3 liters. That's how much he had here. And also the question says how much of the 80% was used. How much of the 80% was used means I don't know how much he used. How high was this little jar? I don't know, so I'm going to call it X liters. That's how high it was. Maybe it was 3 liters and 2 liters. Maybe it was 3 liters and 5 liters. I don't know how many liters, so I'm going to call it X. Now I also don't know anything about the 60%. It doesn't tell me how many liters that was. But I do know that I'm mixing these two guys to get the final mixture. So if I had 3 and 2, I would get 5. If I had 3 and 7, I would get 10. If I had 3 and 3, I would get 6. I do have to add these 2 liters. So I'm going to say the final mixture is 3 plus X liters high. That's how high this jar is going to end up being. Now the equation I'm going to get is going to relate the liters to the pure concentration. 3 liters add a 30% concentration. 30%, change in decimal is 0.30 or 0.3. And I add to that X liters at 80% concentration. And when I mix those two, I get a concentration that has 3 plus X liters at 60%. So the pure liters of the sulfuric acid is 30% of 3, 80% of X, 60% of 3 plus X. I like rewriting it as 30% of 3, 80% of X, and then 60% of 3 plus X, the combined liters. And then I go ahead and solve this equation. So I found X to be 4.5 liters, and X represented how much of the 80% I need. So we say 4.5 liters of the 80% solution, let's say, call it, needed. And it's also important to notice that this is we just found this to be 4.5 liters needed. Now if you're getting a 60% concentration, 60% is 30% away from 30%, and 60% is 20% away from 80%. Since this concentration is closer to the 80%, the answer makes sense that I need more of the 80% rather than I would of the 30%. Example 7, we have how much water, this is important, should be added to 4 gallons of a 5% solution to dilute it to a 3.2% solution. So the key thing, remember, is what is the final percentage of the solution I need? How much water should be added to 4 gallons of a 5% to dilute it to a 3.2%. The tricky thing here is that water has so how much water, we know that water really has none of this herbicide business, so we'll say it has nothing. It's pure. Water is pure and it has none of this solution in it. That way we have the 3 percentages to work with. So we want to dilute this down to 3.2%. We started with a 5%, we want to knock it down to 3.2%. That's why we add water with it, which has none of this solution. It's pure water, so it contains 0% herbicide. So the final solution, we have a concentration of 3.2, and we mix water, which has none of this herbicide, with some 5% mixture. The question says how much water should be mixed with 4 gallons of a 5%. So we know the 5% is 4 gallons high, and we don't know how many gallons the water is, but we do know again that we add these two together to get x plus 4 gallons of the final mixture. So getting our equation for the pure herbicide solution, we have 0% of x gallons mixed with 5% of 4 gallons. Remember, 5%, move the decimal, invisible decimal at the end twice to the left, because 5% means 5 divided by 100. And when we add those 2 gallons together, we get a 3.2%, I'm sorry, at x plus 4 gallons. So move that decimal twice and you get 0.03 times x plus 4, and then we solve this equation. So we've solved the equation. I multiplied both sides by 1,000 to get rid of the decimals, and also the 0 times x went away. And we end up with 2.25, which stood for right here the gallons of the water. So we need 2.25 gallons of water to dilute this solution. And notice we need less of the water because 3.2% is closer to 5% in concentration. So we just need to knock down the concentration a little bit. That's why we need more, 4 gallons of the 5% and less gallons of the water. A student takes out 2 loans. One has 6% annual interest and the other one has 4%. And the total amount of the 2 loans is $5,000. And the interest earned after 1 year is $244. Find the amount of each loan. So we're looking for 2 things. Okay, we're going to use the I equals PRT formula from our notes. Money put times the rate times the time spits out the interest. So the easiest thing to go through is fill out the interest rates. 6% in decimal form is 0.06 and 4% in decimal form is 0.04. Those are the 2 things we know for sure. We also know that the total interest after 1 year is $244. So time we know is 1. That's another thing we fill out. Now this 5,000 is the amount of the 2 loans. So I can't put 5,000 in the first box. I can't put 5,000 in the second box. I do know that that's the combined total is 5,000. I don't know if it was 2,500 and 2,500 or maybe 2,000 and 3,000. So I'm just going to leave that as a combined. Same thing for the interest. The interest they give me is 244 combined. It doesn't say that the interest in each one was this much or this much. So I'm going to work with the top box because it says find the amount of each loan. It means I must be looking for the variable being in my principal box or in this box. So since I don't know how much in each one, I'm going to call one of them, and then the other one naturally would have to be the leftover. Remember the leftover idea that says if I have a 5,000 total and I take some of it away, well, the leftover will be 5,000 minus x. So that's my leftover, and I multiply based on my formula principal, interest rate, and time to get the interest. So the top 3 boxes multiply, and I multiply this by times 1. It doesn't really do anything. And then 0.04 times 5,000 minus x times 1 doesn't really do anything. I filled out my interest box, and now I know that the total interest is 244. So here's my equation. Combine the 2 interest boxes and equal them to the interest that you got combined over the year, and then solve that equation. So we multiply everything by 100 to get rid of the decimals, then I combine like terms and isolate x, and I get x equals 2,200. X was in my principal box under the 6%, so 2,200 at 6% is what the student borrowed. and then I took 2,200 away from 5,000, which was the leftover that I get for my 4% account. And I can do a quick check here. 2,200 at 6% for 1 year and 2,800 at 4% for 1 year gives me those two pieces for the interest that add up to the 244 that the student owed at the end of the year. Again, we have two investments, one at 5%, one at 6%. The total money invested is 2,400 and the total interest after 1 year is 130.50. Find the amount invested at each rate. So we're going to be using I equals PRT and setting up our chart. Again, find the amount invested at each rate. I know the interest rates are 5% and 6%. The time is 1 year. Since I don't know the amount, I'm going to call one of them X and the other one will be the leftover. Total amount invested minus whatever I put here. And I could switch those spots. I could put X here and 2,400 minus X in the other one. It doesn't matter. Multiply the PRT to get the interest. So 0.05X and 0.06 times 2,400 minus X. And I do know that the combined interest is 130 and 50 cents. So I can go ahead and make my equation, which will be the 0.05x, the interest in one account, and the 0.06 times the amount in the other account, which is the interest in the other account, for a total of 130.50, and then we solve that equation. So once I solve that equation by eliminating the decimals by multiplying by 100, I get x equals 1350, and x was in the principal box under what is the 5%, so it's 1350 at 5% that was invested, and then the 1350 got taken away from the 2400 to get the leftover, and that's 1050 at 6% that the person invested. Okay, last example, it says in a survey about 32% of adult Americans believe that they will meet their mates on the internet, and in this survey 480 respondents held this belief. Determine the number of people participating in the survey. So X is the number of people basically participating, so all of the people, and we do know that 480 of them responded, which was 32% of the total people who took the survey. In a sense, we're really asking 480 is 32% of what? Because 480 people accounted for 32% of these total people. So 480 is going to be 32%, remember 0.32 in decimal form, of what? How many people? And if we solve that for x, we end up with x equals 1,500. So 1,500 people took the survey. Again, what we read the problem as and how we deciphered it was that 32% of people accounted for 480, therefore the bigger amount, however many people there were that took the survey, must be that 480 of these people account for 32% of that whole population that took the survey.